Today we're going to talk about gluing the fretboard onto the neck. Today we're going to talk about the different ways you could glue the fretboard onto the neck. Not so much when in the process you do it, but how you do it. And I've got a few necks up here. One has already been glued on. This is a nice flamed maple neck blank with a leopard wood fretboard on it. Already glued on, already shaped and ready to go. These two have got everything set and ready to go, but it's time to glue the fretboard on. Now you'll see here in a previous episode I had prepared this for gluing in carbon fiber rods, and I've got those glued into place, and I've got, in this particular case, actually both of these necks, I've got a titanium spoke wheel truss rod, dual action truss rod already installed. Now what you'll see, the way that I do this, I utilize templates that put alignment pins. In this case, I've got 4 alignment pins, 2 in the front, 2 in the back, on the underside of this fretboard, and I've got the same locations mapped out on the neck blank with 1/8 inch dowels sitting in there, so that the placement of these fretboards is going to be absolutely perfect. Now let's go and talk about how we are going to glue these on. This is the subject for today. You ready for this? A lot of it is going to be a discussion of different ways to do it and the pros and cons. I'm not saying which is better. They all have pros and cons. And so in the end, like everything I talk about, you know, it's one of those things that if it works for you, it's right for you. But I've got 3 basic methods that I'm going to show today. The first one is talking about clamps. Now, using your very traditional C-clamps is the most common way to glue a fretboard onto a neck blank. When we talk about any mechanical clamping, pretty much any one, other than a hydraulic press itself, we are talking about very specific pressures at very specific points. So in this particular case, we've got 6 clamps running down the center, relatively evenly spaced out between each other. Well, it's got about a 1-inch pad on the front and back, and that's putting a clamping pressure right there. Now, different clamps have different amounts of clamping pressure. The everyday quick clamp design is about 100 pounds per square inch of pressure that it can apply. Your standard woodworking F-clamp may be 400, 600 pounds per square inch. You move up into something sturdier like the parallel clamp or a pipe clamp, you're getting about 1,000 pounds per square inch. And then when you're working with C-clamps, you're going to get maybe 800 up to, for a big honkin' C-clamp like this guy here, maybe about 2,000 pounds per square inch of pressure that you're getting with those clamps. That's a lot of pressure. How much pressure do we need to glue a fretboard on? That's the interesting thing. Most glue manufacturers for your PVA glues are going to say somewhere around 100 psi, and they'll say it can go up to maybe 250 psi if it's working with hardwoods, which typically we do in guitar making. So again, pounds per square inch. How do we perceive that? Just because we have, let's say, 500 pounds per square inch with this style of C-clamp, maybe 800, but let's just call it 500 pounds per square inch, that doesn't mean that we've got 500, 1,000, 1,500, 2,000, 2,500, 3,000 pounds per square inch on this. It doesn't work that way with mechanical pressure. Okay, so what we've got is we've got 500 pounds per square inch in this location, and then in this location, and then in this location, and so forth. And that same 500 pounds per square inch is now spreading out and dispersing over the dimensions of the force that it's being applied to. Let's look at the board real quick to kind of show you a quick drawing of what I'm talking about. Okay, so here's kind of a diagram of a neck. So we've got a fender style neck right here in blue. We've got the fretboard in red. Now what you're seeing is, in this particular case, I'm showing 4 clamps. So I've got a clamping pressure coming down from the top in this 4 locations. Now mechanical clamps end up dispersing that pressure in about a 45-degree angle from each direction. So grand total about 90 degrees of span. And so if you look at that clamp and that foot is then pressing out 45 degrees, these are the areas that we're covering. Now, we're also pulling from the backside. So the clamp anchors on that backside, so it's pulling that direction. So again, there is an area in between these clamps that have zero or very little pressure being applied because of the way that pressure is being dispersed by a mechanical clamp. If we squeeze the clamps together and get more clamps in there, we can effectively cover that entire range of that fretboard so that we have at least 100 pounds per square inch of pressure all across that fretboard. Okay, this discussion is being a whole lot more serious than probably it should be, but it involves a lot of math, and math is a hard thing to really have humor about. So I'll try my best. But the next method that we could supply better pressure across that entire fretboard is to use something called a caul. I've got a 3/4 inch piece of material shaped to the same shape as the fretboard that I'm going to use as the caul on the top of the fretboard. So if we drew that caul right across the top and then we disperse that same amount of energy down, you'll see what we're doing is we're getting better coverage of the pressure all along the fretboard because we've extended that 90-degree fan pattern basically to encompass the fretboard more than it did before. Okay, and the same thing from the backside. If we use a caul on the backside, then that's extending that out the same way, and we pretty much can have 100% coverage. This is making a lot of sense, isn't it? Now, obviously, the reason that most people think of when they think of using a caul is to also get protection of the fretboard and the neck from maybe C-clamps that you're really ratcheting down so that you don't dent critical pieces of the wood. And here's an example of the neck and the fretboard between a 3/4 inch caul on the top and approximately a 3/4 inch caul on the back. Again, that is dispersing that force along the entire way of the fretboard, and we have pretty consistent coverage. The other thing that you have to look at here is the center. A lot of folks will use a clamp on either side, and some folks will use maybe 20 clamps along here, each side very close together, and that will probably disperse that pressure a whole lot more. But it's a lot of clamps, and you're going to have to spend the time setting them all up and getting everything positioned just right and getting the clamps on. It takes a little bit of time to do that. You know, maybe it's 10 minutes, maybe it's 15 minutes. Now let's talk about the different adhesives that you can use. Your standard PVA, in this case Titebond Original, is the most common used for wood-to-wood gluing. And honestly, most of the time that's what I'm using. It's just as simple, it's easy to clean up, and it works extremely well. This stuff has incredible hold. If you want to try an experiment one time, take 2 pieces of fresh wood, let's call it maybe 2 inches by 2 inches square, put 1 drop of PVA glue in the center of that, clamp it for 5 minutes, let's say 5 minutes, okay? And then try to rip that apart and see how much effort that takes. The other one that is sometimes used is polyurethane glue. Now the specifications, like I talked about earlier, is Titebond recommends for their PVA glues about 100 pounds per square inch, no more than 250 with harder woods. So somewhere in that range is what their recommendation is. Do you need 100 pounds per square inch to be effective though, even though that's the recommendation? Can you get too much? Yeah, I mean the upper range is 250 only because if you get too much pressure of mechanical clamping with these glues and you squeeze out too much, you may not leave enough there to really do the job it was intended to do. So polyurethane glue has about the same amount of ratings as the PVA glue as far as recommendations for pressure. And I should say the polyurethane glue is a total weather and heat resistant glue. With the PVA glues, you could use steam to kind of rejuvenate that glue and separate the fretboard from the neck at a later time. So if you're planning on doing repairs or you want someone else to have the potential to do repairs, then it's a safe bet to use. The polyurethane glue, though, is impervious to heat, to steam. I think it's impervious to a nuclear explosion. I'm not 100% certain on that. I haven't done a test, but I'm thinking so. I watched somebody, a friend of mine, glue a fretboard on with polyurethane glue and realized he forgot to do something. I don't know if it was forgot to put the truss rod in or what it was, but he tried to separate every way that he possibly could, and he could not get that fretboard off. So what did he do? He planed the fretboard off and made a new fretboard to go onto that neck. That's how well that secures. Now, the epoxy is used a lot for oily woods, the coca-colas and things like that that are oily woods. It's commonly used, the two-part epoxy resin, and that creates a really good joint. Now, the thing about the recommendations, at least from West Systems, is to only apply enough pressure to get squeeze out, is what it's calling for. Any excessive amounts of pressure could cause a depletion of the epoxy from the joint and could starve that connection. So you really have to kind of watch out you don't over torque it here. With these, it's a good idea not to do it also. As long as you're closing the gap between the two pieces of material being glued together, you're going to be fine. So that gets to a sub point, and the sub point with that is make sure the back of your fretboard, preferably before you start any of the shaping and slot cutting and stuff like that, is perfectly flat. Make sure the top of your neck is perfectly flat, okay? And that way they'll come together with no gaps, you know, really easy, and you don't need gorilla type pressure in that joint to glue it together. So we spent a little time talking about mechanical clamping. Well, what other type of clamping is there? Well, here's another way that is commonly used to glue things together, surfaces together, and that is some form of air/vacuum type system. This is a relatively small vinyl bag that is designed for clamping things together. Now, it's made by a company called Roar Rocket, which is really famous for clamping for those who are making laminated skateboards. All right, and the thing about vacuum clamping, and I'll try to explain this in the simplest way I possibly can because I'm a simple person and some of it is like really crazy. But what vacuum is, when you create a vacuum, it removes the air from within inside the bag and uses the atmospheric pressure to clamp those items together. So let's talk a little bit about atmospheric pressure. Okay, it all goes down to inches of mercury is one measurement that we use often in that. But we can convert inches of mercury, because most people don't know 29902 standard day at sea level is a standard pressure for sea level, and that's in inches of mercury, and that doesn't really, what does that mean to us, okay? So I'm going to use round numbers. So again, if you're an engineer, scientist, or something like that, don't hate me for rounding up, okay? But just for the simplicity's sake, if you're at sea level, the atmospheric pressure is going to be somewhere around, slightly less than, 15 pounds per square inch. Well, that doesn't meet the criteria of PVA at 100 pounds per square inch. So would it work? And why does it work? All right, so At 15 pounds per square inch, that is even across the board. Okay, so because you have 15 pounds at every square inch, it becomes cumulative. Now let's talk about atmospheric pressure. If I've got a fretboard that is approximately 2 inches wide, approximately 20 inches long, okay, more like 18, but I'm doing simple math here, that is about 40 square inches across there. So when you leverage atmospheric pressure, every single square inch is getting that approximately 15 pounds of pressure, and under a vacuum that becomes cumulative. So therefore 40 square inches times 15 equals about 600 pounds of total pressure on top of that fretboard. So if you think of it this way, if you were to glue that fretboard on and then you were to go out to the gym and you would grab 50-pound plates and put those 50-pound plates on top of here, you would need 12 of those 50-pound plates stacked on top of here to produce that 600 pounds of total pressure. So believe it or not, it adds up pretty dramatically. Let's just switch off of the fretboard just for a brief example so that you can understand how it's exponential. So if we had a guitar body, let's say an average of 200 square inches in that body, and you're gluing on a drop top onto that body, okay, that 200 then times 15 equals 3,000 pounds of total pressure being applied within that vacuum by leveraging the atmospheric pressure. So this Roar Rocket bag is very affordable. I mean, we're talking about a vinyl bag with a valve for our vacuum and a hand pump and this mesh material, all for $80. Really, really affordable for pretty much anybody. So let's give you an example of how this works. So I'm going to slip this on the pins. I don't have glue in here just because I'm trying to show you for an example. But if I slide this in this bag, it's a small bag, so you have to kind of put it at an angle. And then I am going to run this mesh material, breather material. Basically what that does is it allows the air to flow so that you can remove as much of that air as possible, again leveraging the atmosphere. Now this kit does come with this rubber, I don't know, it's kind of a real tacky seal tape that goes inside here. And that's very, very effective, but it's a consumable. You use it up, so I tried to kind of get off easy by getting one of these same systems that the big commercial vacuum clamping systems uses. Not as effective. Air does leak out of here a lot more rapidly than using that tape, and that's probably why Roar Rocket uses that tape and recommends you use that tape. Now we've got the vacuum, and we'll suck out all that extra air. Once it looks like the vacuum's done all it can, we're going to hand pump it the rest of the way. All right, now don't judge me on this one, but the hand pump is very effective, and you just extract as much of that air as you can. Till it just pops off. Now you have got probably a very equivalent pressure to one of those commercial vacuum bagging systems right there. The commercial vacuum bagging system can range anywhere from maybe a $500 investment all the way up to $2,000 or more investment. Depends on how big the bag, what the bag material is made of, and the quality and the heavy dutiness of the pump and the features that it has. All right, here's a pretty industrial vacuum system. It's a high flow system, which means even on larger bags, it will evac that air pretty fast. So it basically runs by cycling on until it gets to the desired pressure. Now in this particular case, I've got a manifold on the side over here where I've got one line coming into the vacuum pump from 3 potential sources, 2 being these 2 bags right here. I've got 2 similar size bags. I can fit 2 guitar bodies in each of these bags, or I could fit about 4 necks side to side in one of these bags. So you can get a lot of productivity out of this. And I've got these zone controls here where I can turn on the air to any of these bags. The third one is for vacuum clamping purposes. I've got clamping pods that will clamp to the workbench and then the workpiece to that, and I can use the same vacuum for that. Instead of being in auto mode, which basically takes it to the pressure and then cuts it off and waits for it to drop a certain amount and re-engages, the auto mode or the continuous run mode would then keep it running the entire time so that you have clamping pressure on your workbench for as long as you need it to be. All right, so that's basically how this system works. The bags that I've got here are made out of polyurethane. They're 30 mil thick polyurethane, which is really, really tough. The vinyl bags are perfectly good and they will work fine, but they are not as puncture resistant as the polyurethane. Polyurethane, you could take a pen and jam it in there and you would have a hard time ripping this material. It is so tough. So that's the advantage, but there's different price points going from the vinyl to the polyurethane. So I really wish I had somebody here with me that could clamp up one of these with the traditional C-clamp and call method, and then I would do one in the vacuum press to see what the total difference is in the timing. But I don't, so let's go ahead and do a live timing here. So I've got my stopwatch ready to go, and I've got everything I need, the 2 necks, 2 fretboards, I've got some glue, I've got a roller, something to clean up, and I've got my vacuum bag over there with my closure device right there. And we'll see how it goes. Clock is running. All right, let's bring him over. Move the camera a little bit. Machine's on, valve's opening. Were you timing that at home? 3 minutes and 24 seconds to totally glue and clamp up. The majority of the time was the glue process, which is going to be at least the same amount of time no matter how you slice it. And probably less than 30 seconds of that was the actual clamping. Compare that to mechanical clamping and the differential that you may have in pressures combined with the extra time that it might take. You probably can't see how tight this is, but that pressure and that polyurethane bag is just stretching and conforming and is holding everything really tight in here. I'm going to give it about 30 minutes and then I'm going to pull it out and just let it rest overnight. But it's going to be rock solid. You'll see. I just want to say that I really don't like gluing on the clock, being timed like that, because man, I just normally like to take a little bit more time and lay that glue nice and easy. I think I should have just done the test from the time that I finished the glue application, because that's the same whether I'm using clamps or a vacuum clamping system. And if you were to look at it that way, it probably only took me, what, 15 seconds per neck, maybe 30 seconds total for the clamping process. So it really is a pretty quick system. Pretty nice consistent squeeze out all along the edges and the front, which means we really had just the perfect amount of glue. It's so easy to use too much glue and have it just get sloppy and go all over the place, and you really don't need that much. So these necks are all set. All I'm going to do is cut them out, do my neck shaping, and pretty soon they will be up to this stage, ready for the fretboard radiusing operation here. That's all I got for you today. Just wanted to explain different methods of clamping and maybe some pros and cons of each one, and pick and choose whatever is best for you. Until next time, remember, no matter what you do, start with excellence.